Lesson 3.5, Day 2. Now, in Day 2 lesson here, we're going to be finishing off the remainder of the goals from the first part of the lesson. Really, we're only going to be covering the first two. We're going to be covering C and D because the second part just talks about real-world application. And honestly, in the real-world application, all they kind of do is try to give you like a scenario of where it would be used, but they still give you a point with an equation. So the real world application isn't all that crucial. It's just they would add the picture on. So today we're going to kind of focus on finding the distance and the perpendicular bisector. So that's kind of the two goals for today, okay? If you look at this, we have a point and we have a line, okay? And they want us to find the distance from the point to the line. Now, maybe this should include the word shortest distance, because that's really what you're trying to do, is find the shortest. Because if we didn't find the shortest distance, there would be tons and tons of answers. And let me graph it, and you'll see what I mean. So let's start by graphing 6, 4. There's point A. And then I'm going to graph x plus 4. So I start at the y-intercept. And then I'm going to do my slope. I'm going to do a couple the other way just so I have kind of a nice line. And then I'm going to grab something that I can use kind of as a ruler here. And so here's my line. Now, if you asked me to find the distance from this point to this line, there would be lots of ways I could draw this. Like I could calculate the distance here. I could calculate the distance way down here. So really what they're asking you is they want the shortest distance. And that's how the previous lesson, 3.4, actually comes in. In lesson 3.4, they talk about that the shortest distance has to be perpendicular. Okay, it just has to be perpendicular. Because this is a line, you really can't bisect it. So it just needs to be perpendicular. So in order to be perpendicular, so what we want to do is we want to draw in a line, essentially right here, that is perpendicular. So if we were in class, I'd be asking you, how do we make something perpendicular? And then you would be telling me slopes. So if we go back to the original line, the slope of this is 1, which means a line perpendicular would be opposite and then reciprocal. So I'm looking for a slope of -1/1. So if I take this point A and I do a negative slope, I would go down 1/1. But if you notice, I'm off my graph and also I'm going away from the line. So let's just go in the opposite direction. Let's go up 1/1, up 1/1. Up 1/1. And do you notice I hit right there? So if I were to connect this, now I actually don't really want to connect a full line because I only want the distance from the point to the line. So I really don't want this point, or I don't really need it. I only need to know this distance right there. So now what I need to do is I need to calculate the distance from A, which I already know, to the new point on this line. So I need to figure out what this point is. So it looks like it's 3, 7. And now from here, I need to calculate the distance. So again, in lesson 3.4, we worked on practicing the distance formula. So hopefully it should be fairly fresh in your mind. We're going to take the second x minus the first squared plus the second y minus the first squared. And then we're just going to work this out. So 3 minus 6. And if you want, you could type this in your calculator. So I get 9 plus 9, which would be 18. And 18 is not perfect, so we'll go to our calculator. And if you want to leave it as the square root of 18, you could. But if you want to approximate, you'll just have to kind of round there because you see how it's an irrational decimal. So how about we'll just call this about 4.24. It doesn't really tell us what to round to. It doesn't tell us not to round. So we'll just go ahead and round that off. And that is how you find the distance. So why don't you go ahead and pause the video here and try number 2. Okay, hopefully you paused it. I'm going to tell you what the correct answer is, and then I'll still work it out. But for those of you, if you get it right, you could just fast forward through my work. So I got the distance to be the square root of 5, which is also about 2.2. Obviously, I did some rounding. So if you got that correct, go ahead and fast forward on to the next question. Otherwise, I'll go ahead and work it out. So 3, negative 2 is my point. And then I need to graph the line, and because it's in slope-intercept, we start at 2, and then we do our slope, down 1 over 2, down 1 over 2, and I usually just like to do quite a bit of slope, just so that I have a nice straight line. Sometimes I even like to go in the opposite direction, just because that way when I do go to connect, I know it's just a nice straight, straight line. Okay. And really, the connection of the line is not probably as crucial as the dots themselves, because you need to just see where it crosses. All right, so if we look at our line, we have a slope of negative 1/2, which means to be perpendicular, we have to do the opposite, so positive, and then reciprocal. So this is the slope I'm looking for, or using. So from B, I'm going to go up to 1, 2 over 1. Do you see how quickly I hit? So this distance right there, that's the distance I'm going to be calculating. Now some of you might ask, will it always hit in a nice easy spot? And the answer is, in your class, yes. In real life, potentially no, but in your class, yes, they always do have you guys hit at a nice spot. So you don't have to worry about finding the point of intersection in a more difficult way. All right, and then this would be 4, 0. All right, so now we're going to use the distance formula. So I'm going to do x, so x2 minus x1, so 4 minus 3, and then 0 minus a negative 2. And so that would be 1 squared, 2 squared, so that's really the square root of 5. And then again, if you type it into your calculator, you get the 2.2, okay? All right, so let's move on to the second part, because that was really like the first goal of the day. So the second part is now we're going to be doing the perpendicular bisector, okay? And so you'll see kind of the difference if you look here. Do you see how they give you 2 ordered pairs? In the previous section, they were giving you 1 ordered pair with an equation. Now they're giving you 2 ordered pairs. So it's a different type of question. They're not going to be asking you for the distance on this. They're asking you to write the equation of the perpendicular bisector. So we don't have to do any distance. So perpendicular bisector. Basically what I would want you to be thinking about is perpendicular is going to be opposite reciprocal slopes. Because remember, perpendicular means that they cross at 90 degrees. So we basically need to use the slopes, okay? Bisector means that you've got split in half. I don't know why I put an N in there. Split, not splint. Split in half. That's perpendicular bisector, okay? So let's take a look at this. Let's go ahead and graph this. Negative 1, 5. Negative 1, negative 3. Just going to go ahead and use this so it's straight. Okay, So they want me to write the equation of a line that is the perpendicular bisector to this segment. So I need something that crosses this at a 90-degree angle and halfway, because remember, it's split in half. So let's do perpendicular first. How do I get perpendicular to this? Okay, well, this is vertical, right? So even if I were to calculate the slope, which you already should know the slope, but if I were to calculate the slope, I would do the difference of the y's over the difference of the x's. And so what you should be noticing is this is undefined. So anything I'm going to do here is going to be an opposite reciprocal, but you can't really do opposite of 0. So that doesn't change. So I mean, I guess negative to positive, but basically what you end up having is a slope of 0. Now it doesn't matter if you want to put the 8 in the bottom, because 0 over a number is going to be 0. So what you're basically telling me is this is going to be a horizontal line. So see how it says write the equation? I can already tell you right now the answer is going to be y equals. That's going to be my answer because it's horizontal. But the problem is I do need to figure out the number. Now, to figure out the number, I need to know how far, like how long this is. Okay, so if we just count, that's 5 and 3. So this whole segment right here has a length of 8. So bisector would be halfway. So if we just count 4, 1, 2, 3, 4, that means there's 4 below. 1, 2, 3, 4. So this would be my halfway point. So now this is the equation of the line. So this is the line that they're looking for. So now I just need to finish off my equation. So if it's horizontal, it's just y equals that number. Now this one is unique because the line was vertical. So if the line is vertical or if the line is horizontal, it's fairly unique like this because you can count it out. Let's take a look at number 4. Let's do number 4 together and then I'll have you try one on your own. Today's a fairly short lesson, so it doesn't have a lot of problems to it, but they are a little lengthy, so each problem is a little longer. Okay, if we actually graph this out, just by graphing the original, are you noticing that it's on an angle? It is not vertical and it is not horizontal. So it is on an angle, which makes it more difficult because unlike the problem from above, we can't just count it. And we don't, like this one, we knew the slope was undefined. We don't necessarily know the slope here. So let's start by figuring out the slope. Now, if you want to count this on the graph, you could count it. So you could just do rise and run. That would work. I'm going to go ahead and use the ordered pairs. So I'm going to do the difference of the y's over the difference of the x's. And so I get my slope to be 1, which means my perpendicular slope would have to be opposite reciprocal, which does look kind of funny that it's 1 over 1, but that's okay, okay? So that means a line that's going to hit this perpendicular will have that slope. So we've got the slope just like we did up here. Now we need to find the halfway point. Well, because this was vertical, we could just count it, but this one's not vertical, so you can't really count it because how do you count like half a box and then how do you count that? So we need to figure out the halfway point, and that is going to be the midpoint. Now we haven't done midpoint in a while, so I'm going to go ahead and write down the original formula for you. Whoops, that's y's now. So that is our midpoint formula. So I'm going to go ahead and calculate the midpoint. So I'm just using the numbers up here. So I'm going to take the x's and add them together and divide by 2. And I'm going to add the y's together and divide by 2. So that's 1 divided by 2, and that's negative 1 divided by 2. Okay? So now I have the slope and I have the point halfway. So half, negative half, which is right here. Now, I don't really need the graph. The graph is more just a visual to help me. The only thing that the question really is asking for is the equation of the line that is the perpendicular bisector. So I really don't need the graph other than just as a visual and as my work. Now, I have the slope and I have the midpoint. So really, I mean, this isn't going to be perfect, but the line is right here. That's the line. So I need the equation of that line. Well, they never told me what form to use. So if it was me, I would probably use point slope. Because point slope is going to be faster. So you would do y minus your y value, so you'd have to zip zap, is equal to your slope, and then x minus your x value. And then I would be done. This would be my answer. Now, if you wanted to continue on, or if you wanted to put it into slope-intercept, you could do that too. So if you want to do slope-intercept, you remember I've shown you two different ways to do that. But the other way to do that would, or the easiest way for me to do that would be just to go ahead and distribute. So negative 1 times x, negative times a negative would be a positive, and then I would subtract the half, and I would get y is equal to negative x, and then this becomes a 0. So this right there is my answer in slope-intercept. Which, if you look at my graph, even though my graph is not perfect, notice I can see that it does go through the 0 mark. So I know that is actually the correct answer as well. So on the answer key, I will show both. I will show point slope and I will show slope-intercept, but you only have to do one. You don't have to do both. So this one is slope-intercept. Okay? Now there's only one more example, which is number 5. Why don't you, again, pause the video here and try this, but why don't you pause it and try not to look back at your previous work to see if you can do it on your own. Okay, hopefully you tried it. The correct answer, again, I'm going to give you the correct answer first, would actually be y equals, let me give you both actually. I was trying to give you just the slope-intercept. It would be y plus 1 is equal to 1/2 x plus 2 if you did it in point slope. And if you did it in slope-intercept, it would be y equals 1/2 x. The intercept, again, would actually be 0. So you can give me one or the other. You don't have to give me both, okay? So if you got those right, you are all done, and that does wrap up our chapter. If you did not get that right, let me go ahead and work that out for you so you can see the correct answer. So negative 4, 3, 0, negative 5. Now remember, the graph, again, is more of just a visual. You don't actually need the graph. It's just to help you kind of visually understand what's going on. So here's my segment, and again, you can see it's on an angle. So I need to know the slope so that I can get the 90-degree angle, and I need to know the midpoint so I can be halfway. So it doesn't really matter which one you do first. I typically just do slope first just because, just keep up the pattern. So I'm going to go ahead and work it out, and if you want to count from the graph, you can do that too. So I get my slope to be negative 2, but remember, that's the slope of this line. So you need yours to be perpendicular. So you're going to do opposite, so it's going to be positive, and then you're going to do the reciprocal, which is 1/2. And you can see in my answer, that's how I got the 1/2. Now I need to do the midpoint. And again, it doesn't matter which one you do first. If you calculate the midpoint first, that's okay too, okay? So the midpoint is, we're going to add the x's together, and we're going to divide by 2. And we're going to add the y's together and divide by 2. So that's going to be negative 2 and negative 2 over 2, sorry. Negative 2 over 2, which would be negative 1. And then this would be negative 2. Negative 4 divided by 2 is negative 2. I cannot, sorry, simple math here today is not my strong suit. And then this would be negative 2 over 2. So this would be negative 1. Okay, that looks like a much better midpoint. All right, so that's my midpoint. And again, if you want to do it on the graph, here's your midpoint. And then your slope would be up 1 over 2, up 1 over 2. And again, you can tell where the intercept is right now from your graph, if you like to go point, slope intercept. But if we use our midpoint and if we use our slope, we can write our equation. So again, if you want to use point slope, you're going to go y minus the y value. So that's how it kind of zip-zaps. And then we're going to do our slope. And then x minus our x value. So again, it zip-zaps. So that's how I got the first answer. Now again, if you look at the graph, you can see the intercept is 0. But if you're not sure, you can always take point slope, and if you distribute, so half of x, half of 2, and then if you subtract the 1, you'll notice that the intercept essentially is 0. And you don't necessarily have to write that 0. Okay? So that concludes the final lesson of chapter 3.